Okay, we have to work out 2 1/4 times 3 1/3. Right, we've got two mixed fractions here and we're multiplying them. You're not allowed to break them up the way you can do if it's addition. So if we had 2 1/4 plus 3 1/3, okay, you can break that up into 2 plus 1/4 plus 3 plus 1/3, okay, which is 2 plus 3 is 5, and 1/4 plus 1/3, put them over 12, so that's 3/12 plus 4/12, so it comes out as 5 7/12, okay? But this is multiplication. You're not allowed to break it up like that. What you have to do is rewrite these as improper fractions or top-heavy fractions, okay? And to do that, you do that times that plus that over that. So it's 4 times 2 is 8 plus 1 is 9 over 4. Okay? Times that times that plus that over 3. So 3 times 3 is 9 plus 1 is 10 over 3. Okay? Now, before you dive straight into the multiplication and do 9 times 10 over 4 times 3, that's correct, but I can make your life a lot simpler. When you have a multiplication of fractions, always check for cross-cancelling first, okay? It makes your life so much easier. Can we cross-cancel? Yes, we can. Look at this. 3 goes into 3 once and into 9 3 times. 4 and 10. 4 doesn't go into 10, but 2 goes into both of them. 2 goes into 4 twice, and 2 goes into 10 5 times. See, much easier. So it becomes 3 times 5, which is 15, over 2 times 1, which is 2. We're not going to leave it top heavy. We have to write it as a mixed fraction. You should always do that, whether it tells you or not, if it's your final answer, okay? 2 goes into 15 7 times, remainder 1. So therefore, this is 7, remainder 1 out of 2. So it's 7.5. Good. Okay, for the second part, we've been given these two fractions and these 4 numbers, and we have to put these 4 numbers in these 4 boxes to make the addition of these 2 fractions as big as possible. What a stupid question. We're putting numbers in boxes. It feels like we're colouring in or something. Why don't we do some proper maths like this? Let's just get through this. Okay, so I talked about addition of fractions here, and you can split it up for addition. So it doesn't matter the order. We can swap whatever the 2 numbers we put in these boxes here, we can swap them around. And to make the whole thing as big as possible, because they're the big numbers, we need those numbers as big as possible. So we're going to choose 5 and 6 to go in there and there. Okay? Because they're the big numbers. They have the largest influence on the size of the addition of these fractions. And like I say, the order doesn't matter because order of addition doesn't matter. Okay, so next we're going to put either the 3 there and the 4 there, or the 4 there and the 3 there. So that means it'll be either 1/3 plus 2/4, or if you put the 4 there and the 3 there, it's going to be 1/4 plus 2/3. So whichever one of these is bigger, that's our answer. So let's quickly work these out. Now 2 over 4 is a half. Yes, I realise we could do 1/3 plus a half, but I'm going to leave it as 4 and put everything over 12 because that's what this one is going to be, so we can compare them. So put everything over 12, so 1/3 is 4/12 plus 6/12 is 2/4, or a half. So that's 10/12. Okay, this one over 12, 1/4 is 3/12. plus 2/3 is 8/12. So that 3 plus 8 is 11. That's the winner. Okay, so we want 1/4 plus 2/3. There we go. We choose that because 11/12 is bigger than 10/12. So that's the way around that we want the 4 and the 3. Okay, so there's the answer. But like I say, it's also perfectly correct to all. If you had put the 6 in that box, that would be fine. So 6 1/4 plus the 5 in that box, 5 2/3. That's equally correct, either of those, because like I say, when you do addition of mixed fractions, you can split it up like this, and order of addition doesn't matter. So you can move them around. Okay, done.